Okay, so let's get started. We're going to be taking a look at setting up and working with our VTEC programming in our Link G5 and G4X systems. Now, our VTEC programming is going to be specific for Honda engines. It could be a B, D, H series engine, C series, F series, K series. Honda used VTEC on so many different engines. It's very common if you're going to be tuning a Honda engine, it's likely to be equipped with VTEC. Now, how we program this is pretty specific with the Link. We want to go in and be able to control that VTEC switch point. So we want to do that based on engine speed, typically throttle position and manifold pressure. We don't want VTEC engaging, let's say at part throttle cruise. We want it only at higher RPM, higher load conditions for it to actually turn on, because we actually have two different cam profiles built into the same camshaft design. We have a low and a high cam. So low cam, non-VTEC, high cam, that's when VTEC's engaged. And we switch between the low and high cam lobes on the cam by locking a third rocker arm in the rocker arm assembly. And that's all controlled with oil pressure, which is controlled from a VTEC solenoid. So when we're programming with the Link and we want VTEC to engage, we're going to be turning on the VTEC solenoid, allowing the oil pressure to flow through the cylinder head, through the rocker arm assembly, and allowing a pin to lock and keeping VTEC engaged. And then when we want it to disengage, we turn off the solenoid, we cut off the oil pressure to the cylinder head and rocker arm assembly, and then that pin slides back and we go back onto the low cam operation. It's a very basic and ingenious system that works extremely well, and it is reliable. Engine's been out for quite some time now, and there's no issues with the VTEC functionality. Now, we also have other engines, such as a Nissan SR20 VE engine that has a similar type of design. So we have a oil control solenoid. There's actually two of those on a SR20 engine. And when we want the equivalent VTEC or the high cam profile to turn on those VE engines, we'll go ahead and turn the solenoids on and engage that high cam. And when we want it to turn off, we'll disengage the high cam, go to low cam. So Nissan replicated a similar type of design on an SR20 VE engine. So how we program and work with things here on a Honda engine will be applicable to an SR20 VE engine. And to my knowledge, I don't think there's another engine that had this type of design. I could be wrong, but those are the two engines I'm only familiar with tuning that had this type of low and high cam locking type of design with an oil control solenoid. This is not the same as variable valve timing. So variable valve timing is when we actually have oil pressure through a oil pressure control solenoid, and that's going to be allowing more or less oil pressure into a cam gear that actually rotates the cam back and forth as the engine is going through the auto cycle. Essentially, we're controlling the dynamic overlap between our intake and exhaust cams by controlling the variable valve timing. So a lot of times people get confused. They think VTEC is variable valve timing or variable valve timing is VTEC. They're definitely different. And if we're dealing with an engine like a Honda K series, it actually has both. It has VTEC and variable valve timing. And what we're going to take a look at here in this tutorial is an example file from a tuned Honda K24 engine, so we can see how everything's going to be laid out and just taking a look at some specific details of how you should structure your calibration file. Let's jump in here and take a look at that file to begin our training course here. So we're going to go up to File. Let's go to Open, and we're going to go here to Desktop, and let's go to our G5 course packet. Then we're going to move here into our sample tune files, and we're going to go ahead and grab, I have them labeled here. There's a K20 Turbo RSX, K20 NA Flex Fuel, K20 an NA ITB, so you have a couple different options here. We also have a Honda S2000, AP1 S2000, so a lot of different examples. Let's first just take a look at the Honda S2000 example here, because the F series engine, so F20, F22 engines, those only have VTEC. They don't have variable valve timing. We can take a look here then at the Honda K series engine. So let's look at the most simplistic VTEC operation here. This would be the same as you'd find on a J series, D series, B series, H series, C series, which would be NSX engines. They all have this basic VTEC, so they don't have variable valve timing on top of that. So let's go ahead and grab our Honda AP1 NA tuned file here so we can take a look at this. It's going to ask me, this file's been modified. Do you want to save it? No, that's whatever the current file is open right now. So let's go ahead and just get rid of that file and open up this calibration file. Now, first thing we want to talk about here is the VTEC setup and programming. So how do we set up VTEC? How do we actually engage it? How do we program it into the right conditions? What we want to do here is actually move all the way over here to the right And I have 2 pages labeled VTEC Fuel and VTEC Spark. So if we're dealing with a B, D, H series, C series, F series engine that just has VTEC, so not variable valve timing, these are the 2 tables that we'll be dealing with here primarily for doing our tuning. Let's go to the VTEC Fuel table, or Fuel Tech page, I should say. So looking at this, we're going to find in this particular file, and this is from a G4X plug-and-play box for a Honda S2000, we're going to find that we have our general purpose output 1 assigned for the VTEC solenoid operation. And this is actually built into the base file from Link for that plug-and-play S2000 application. So we can take a look here. The labeling is called VTEC solenoid for this particular output. The output is from ignition 5. So the ignition coil output 5 is used for VTEC activation. We can see here the active state is showing low. Now here's what's interesting. When you're talking about this plug-and-play application from Link for a Honda S2000, the active state sends a low side trigger output. What's happening here is that there's some hardware changes in the box to be able to support a low side output. So a low side output means that we're going to be grounding the output that we're trying to control. A Honda VTEC solenoid is grounded already to the cylinder head, and then we activate it with a single 1-wire 12-volt activation source. So I think it's a yellow-green wire or green-yellow wire is typically the colors going to the VTEC solenoid. It's just a single wire. That's going to be high side output. So normally, let's say we're doing a universal application, we're using a Link G4X Fury or Extreme, or in my case, the Voodoo Pro G5, we would set the activation state as high and not low. It's just the way that Link does this on their plug-and-play files with the plug-and-play S2000 box. So this always trips me up. Every time I look at the file, I'm going, oh, the active state's incorrect. It's actually not incorrect. It's just the way that they deal with the hardware internally on the box and actually activating the state. So it's just some kind of oddity they have going on with that plug-and-play box. So normally it would be a high side output to control the solenoid. In this case, it's, again, set low because of some internal hardware modifications they've done. Now, the switch logic, we have 2 conditions that we're showing that we're meeting here. We have engine speed and we have throttle position. Now, you could do a 3rd condition, and that could be based on manifold pressure. So typically the 3 things we need to worry about: engine speed, throttle position, manifold pressure for VTEC to engage. So taking a look at this, we have condition 1 and 2. Oh, it is N3. Okay, I didn't see it was cut off there, N3. So we actually have 3 conditions specified. Engine speed needs to be greater than, and this is where we want the VTEC to turn on. This is our on point. Right now it's showing 3,600 RPM. That's pretty low, but with stock camshafts, usually you can gauge VTEC relatively low if you have good bolt-on breathing modifications on the engine, so good intake, header, and exhaust design. Now, throttle position. We have to be above 50% throttle, and then map pressure here. This is in units of PSI. Let's go click U here. That'll switch it back to kPa. What this is saying here is that we have to be 50% throttle and 80 kPa of manifold pressure for the VTEC to turn on at 3,600. We've set this up at a pretty high throttle angle and manifold pressure because if we want VTEC to engage, we definitely don't want it engaging if we're at part throttle and cruise, because we're setting a lower RPM threshold here for engagement. So we set our load conditions, our thresholds, a little bit higher if we have a lower engine speed where VTEC wants to engage. Now, throttle position here, 50% is pretty good. Manifold pressure, 70, 80 kPa is probably normal for a naturally aspirated engine to engage VTEC. When we're talking about the engine speed, this is very specific to the bolt-on mods and the camshafts you have installed on the engine. What we can do here in order to figure out where the engine speed threshold should be for it to engage, we can actually go in and set up our main field table. So field table 1 active. This is going to be low cam operations. This is with VTEC off. We'll dial all this in 100% so we hit the desired target lambda, as we described earlier in other training tutorials, how to dial in our field table. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.